All right, so let's start with this. That's awesome. And mathematically correct. Very nice. All right, awesome. So a lot of really good responses. Actually, I mean, so a lot of really good responses on the reading assignment, especially for the first two questions, and awesome responses for the third one, especially because it's the old thing. You don't have to think a baby is cute. So I had a couple of people that were like, nah, no, not cute. So which would that and that's fine. Like that's allowable. What do you call it? I thought the baby was cute. Actually, yeah, yeah, yes. You said it. The baby was loud. Yes, I've had that. I get that. Usually, one or two people in class are like, "Yeah, the baby was kind of loud." So, um, fortunately, that's how babies are. So when you gotta work with one, that's what you gotta deal with. So sweet. Okay. Um, so let's start with y'all's answers for the first two questions. Correct. So the first question I was asking that is basically what moves the graph left, what moves the graph right. So what moves the graph left, what moves the graph right, and what is this?
Um, Anything on the outside of the absolute is up and down.
So anything on the outside, anything being added or subtracted on the outside. So like what you guys saw, it was +2 on the outside. What did that do to that original graph? If it's look, it's fine. It's so this is left two. So this is where I'm trying to get to. And you guys answered this right on some of the last class. So don't doubt yourselves. So everybody I saw on the reading side answered this absolutely right. So don't doubt your answer, trust your instincts, trust what you got. So this +2 on the outside moves the graph up to, yes. So this is up. Give you a little bit of vocabulary too that you'll see on the later questions in that homework. Sometimes the words they use for this, they'll say to move the graph up to, but they also use the word shift it up to, or if they want to be really, what do you call it, formal, they'll use the word translation. So geometry, when you take a picture and just move it, that's called a translation. So they will call this a vertical translation. But so just know they'll use kind of all three of those words. Okay, this is up to. What about then -2 on the outside? What would that be? That would be down to. And then the +2 on the inside, that was left. The movements left and right, the only thing about them is they are slightly counterintuitive. The plus moves it left instead of right, like you would think. Yeah, so it's just the opposite of what you would think. Did that weird anybody out, throw anybody off, or? All right, then what about this -2? What did that do to the graph? And this is part of what the homework is gonna do is, there's some problems where they're not even gonna have you graph it. Really, they just want you to predict what happens to the graph. So these are all vertical or horizontal translations or shifts. And so we saw this for the absolute value. The question is, does this pattern hold for all the other graphs that we saw? And so let's test that out. What I'm going to do is I'm going to give you guys let's do something like this. We'll do maybe x² + 3. So we're going to go ahead and graph this and see if it follows that same pattern. So what would you expect? So first of all, what shape would you expect this graph to look like? Would you x², so it's a U, and then the +3, what do you think that'll do the graph?
Like 3.
Yeah. So move it up 3, but let's actually confirm that. So we don't so we'll just do one example to confirm that. Usually I'd like to do 2, but so what I want you guys to do then is go ahead and graph this. Let's see if that's what we see. Let's see if we see that same U from Tuesday, but it's up 3. Words that said. Is the theater really dead? And how to read something? It's just you're strange Austin day to the ocean up. So you should really be sitting up to the but I think a good way to think about it, it would be, imagine that what's happening in Spain. I don't want to just why should you shoot? Let's say they're shooting out there, the ocean. Between and manually that's exactly how. Only that. That's what I would say. Vice versa. It's that these wild so I do during my own. Oh, I wanna come here and every part of me. There's blood on my hand. My lips are clean. In my darkness, I remember mama's words reoccur to me. Surrender to the good Lord, and then wipe your slate. Take me to your river. High. Oh, take me to your river. High. You're so off now. Going as a man with many clouds. As my sins flow down the Jordan. Oh, I wanna come in and every part of me, but there's blood on my hand, and my lips are clean. Take me to your oh, take me to your Is not alone. One more. Oh, take me to your river. Huh? Oh, please let me know. Take me to your river. Nah. Ah. Mm. Mm. All right, so let's kind of work on this. So the one thing I noticed, you guys again, kind of like kind of like I was, emphasizing on Tuesday, you guys are doing the sketch, but you're not. So, um. I call it. So when I asked you to graph this, so what I told most people do is you gave me the U, we did a 3. But again, like that's just a sketch. There's a ton of details. And the detail is the graph. Because your line, your U could be too steep, it could be too kind of fat at the bottom, like it could be wrong. So we gotta really work on this, like, again, it's teaching for 16 years. I knew and taught people in college before that. But you guys are completely capable of doing this for real and not just kind of making it short. Because I didn't grow up with a ton of snow. So I'm saying, like, I actually think that you guys are actually, for the classes that I usually have, you guys are a smart class. You're very good at picking the patterns. But right now you're using the patterns as a shortcut, so you could just boom, 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 let me get it done, let me get out, so I can do whatever else I want to do. And you're smarter, you're more useful than that. So in order to get the graph going and not just the sketch, we kind of look back at what we did on Tuesday. What do I do every time I get a graph going? Yes. We're gonna make a T-chart with the X and Y. And I'm gonna go ahead and pick some X values, plug them in and get the Y values going. So we can do -2 through 2. So let's kind of work this out one by one in pieces. So when you plug in -2, what do you get? You're gonna get 7 here, 4. And then +2, perfect, yes, that gives you 7. What about when you plug in -1? 4, that gives you 4. What about when you plug in 0?
3.
3. 4. 4 and then 7. Yeah, and that's perfect. If you see the pattern there, just run it. Any questions on the calculations? With -2, 7, -4, 0, 3, 4, 7. So we do get the U, like we predicted. So again, part of the reason I do this is if you just memorize, oh, this is this and this is that, then later on in mathematics, when there's a couple small changes to things get wrong there. So anyways, well, I'm trying to get you guys to establish a pattern, not by memorizing, but really trying to set out doing a little experiment. So we do get the U. So every time I have an X squared, I'm gonna have it. And notice that this U is moved up 3 compared to our X squared that we get on Tuesday. So this plus is really every time. So it doesn't matter what function you're looking at, a plus outside always moves it up 2. That's gonna hold. What is the domain of this? That is equal to that. Negative infinity. Negative infinity to positive. What do you think?
We make a bracket and we deal with.
So brackets and
Oh, wait, no,
3.
3,
Yeah,
3.
perfect, yes.
Oh, we
Yeah.
can-
So our Y value there is 3 and then,
Positive infinity first.
perfect, yeah, then up to infinity. What's my X intercepts? 0. Does it cross the X axis at 0? Or, but, so what do you, you guys had the right idea, you just, what did you mean by zero? There is, yeah, there is, so, but zero on a graph unfortunately doesn't say there isn't one, because zero is a position. So yeah, you can say something like not applicable, does not exist, something like that. Or honestly, on the test for me, you can just say there is. All the same. What about the y sets? Zero positive. I'm still gonna ask you to identify these at the top. Any questions on getting the graph going, the graph, that stuff?
So there's parentheses around it, it would move the left, right?
Yeah, so if there's parentheses around it, it will to the left. That's all. Um, All right, so then the next one. Yes, let's do square roots. So we're gonna do square root of x, but now minus one outside that square root. So based on what we saw with the reading, what do you predict the minus one does? So move down, move it down one. So this should be that same square roots. What do you call it? Yeah, that same square root shape. What would you call the square root shape?
Like a super long line.
Yeah. Yeah, true. It's, and the thing with it is, so it does, depending on how you graph it, it does kind of look diagonal. It's really supposed to be curved. So it's really supposed to kind of come up like this, flatten out. Yeah, so as long as you just have a name in your head for that shape, but it's gonna be that shape down one, is what we expect. So. Same thing, when you have you graph this, go back to your notes from Tuesday and just pick the same X values. Pick the same X values. This is how all experiments work. We control your input. We change something about the equation, so let's see how that changes the input. So go ahead and get the graph going and then do domain, range, X intercept.
Take a little, but it after, that's one pretty fair round. Right on this one, you can take one of these. Take values. Just wait and see, you don't know.
So you get the, which brings me to my, like, and you, you can minus the one. If you, railroad and minus, like, if we force for root is to minus one, that's true. That's the. So. So. I found it on. One year. Um, so, I did talk about forward conflict. That's the topic. Then,
So, like on this, you think about it, but the main of my end value, I'm far left. And all the little things that. Focus on the little arrows are counting, the whole picture is that is going around. So. So that's why I do think it's probably. Yep. Under the. So that would flip three, or like that would be the 12 minus 1/3 with 10. So you still. Well, it just depends on how it's written, so we'll talk about it. The way it's written. Basically. Sort of cursive.
So. Go. Go simply. See. So. Starting in my taking up to the spring and the after down. Goes up from mine. Us like we all have it all. Cause I can't feel anything.
Thing is, what X values did you get? 0, 1, 1, and Y 0, 1, 2.
We're perfect square root.
Yeah, they're perfect squares. And but then also, if you did something negative, you'll see increase square. And then these are nice because I'm not gonna get any crazy decimals. So I can do the square root of 0, square root of 1, or not. Yeah, it's just not nice. Second thing, so several questions about that people asked about the order on this. It's a good question because honestly, so we won't do this in the next problem. But if I wrote this, you do this in two different, you do the calculations in two different orders. So, and this goes back to order of operations. When you're doing these, you can think of the, what do you call it? You can think of the square roots. Well, the square root by itself is actually an exponent. We'll kind of talk about that later on this semester. But it also kind of acts like a set of parentheses. So everything that's under it gets done first, basically. So it's what we call a grouping symbol. So either way, when you see this, you're gonna have to do kind of, well, on this one, we have to do the exponent of the square root first. But this -1, this minus is not under that square root one. So that means we're gonna do exponents and then subtraction. But if I wrote it like this, I have to do everything underneath the square root first, then do the square root. It's just because, again, the square root kind of acts like a premise. And so that's something you have to think about when you're doing these problems is when they switch where that -1 is, it does switch the order. of the calculation. But for ours, you just had to do the square root of x, subtract 1. So when y'all plugged in 0, what did you get?
-1.
Yes, that's gonna be -1, good. What about 1?
0.
0, good. What about 4?
1.
Yes. 4 is gonna give you 1, and then 9,
2.
that's gonna give you 2. And let's graph it, see what it looks. We have this way. We're gonna have 0, -1, 1, 0, 4, 1, and 9, 2. So we do get this little swoop going out. And it is the same shape, it's the same shape as square root of x for Tuesday, but we've moved it down. Alright, I do wanna get you, so what I did see while walking around those, I don't think anybody got to doing domain, range, x-intercept, or y-intercept. And I do need you guys to kind of do it yourself instead of kind of, even if I'm just asking you and you're telling me and writing it on the board. I gotta get you to the point where you're creating that yourself. So I'll give you guys another minute or two to figure out the domain, the range, the x, so same idea. So look at this picture. Just tell yourself not part of that. For the right. What about on the left, where it looks like it's. Here, your domain, serious. Yeah, you're going. This is going with so going. Why not? I know you're scared of the mess. One. So it's. It's weird. So I said. So maybe we'll start. Um, order pairs. Order pairs. Me too. They're looking for. That one. Yeah. You're a really good teacher. We're not playing with this. Let's see what you got. For the dummy.
Bracken. Bracken, or.
Say
Or good one. Bracken, or.
so surprisingly not one.
Oh, wait, hold on.
Zero. So thinking about how far left it goes, this is where it ends, but the x value there is zero. So, zero. So it'd be zero, comma, infinite. Yeah, with parentheses.
Other than that,
So at that point, what is the x value? Yeah, and so just remember, domain is always. Yeah, domain is always x values, you never pay attention to y value. But it is hard so it's hard when you're looking at a y-intercept because you want to say y. But domain is about x values, so you just say x values. But range is about y values.
Right, -1.
Yeah, bracket -1, true. What's the x-intercepts? 1, 0. What's the y-intercepts? 0, -1. No problems. So a minus outside always moves your graph down. Let me move this. Let's do the brackets. Let's do plus. So we're going to do. Okay, that's plus two, but again, from your reading, you saw that +2 inside, move this graph left 2. If we want to test that, to do the same thing to this graph, let's move this graph left 2. The cube though, so what is this graph? What shape is this graph gonna look like? It's gonna look like an S. So our prediction is this should be an S left 2. So same thing, I'll give you guys time, go ahead and start picking X values and get the graph going.
Gonna make your hit point. Make your be the depths of your display. Make it all down there. My soul won't be shaken. Sounding low. Just we could have Wow. So that let's yeah, I think nice. Look at you. Look at you. It's not fun. Very good. I was probably us. That's another. If you thought what was that at the time? Oops. Or sitting in another study. I mean, and you can. Oh, yeah.
I'm seeing you going, almost everybody that it takes place. So you're picking X values. Are you guys sort of getting the picture you expect this? Of what you have so. And if not, you're in a good place. So that's what I'm saying. If not, you're in a good place. There's a reason you're sort of not getting the picture you expect to see. So let's look at what you guys picked. And then basically what we wanna do is figure out what do we do in this situation. If you're not getting the picture you expected to see, like, just, what do you call it? Just problem solving wise. It's like you're playing through Skyrim or something like that. You don't get the result you thought out of it. What do you do in that next play? So. What X values did y'all choose? Said it in,
-4 to.
so you did -4 to 1, okay, we'll get to that, that's a good pick. What about the rest of y'all? -2 and 3. -2 to +1. How many of y'all did -2 to +2? Yes. Yeah. So let's do the same, let's start with that, so what's happening is, she had a really good moment there where she picked the numbers everybody else was picking. Just realized something's off, the number that gets split apart, where I didn't see. So then we'll take her lead from there. Well, let's start with the -2, -1, 0. When you plugged in -2, what did y'all get? 2. Should be 0. The -2 + 2 is 0, 0 cubed is 0. What about -1? That'll be 1, 0,
8.
yes, 1, 2, 4, yeah. So notice you're starting to get these large numbers, and so the thing is, these are correct, but we didn't see large numbers before. So again, you hit some point where you have some expectation and you're not getting that expectation. Strategically, there's 2 approaches. Either you just kind of saint this and basically call something new, or the other option is maybe try picking some other numbers to see if maybe you just missed part of the graph. Because even if you graph this, I think I saw several people with the graph was going. So for those with this graph, when you look at this graph, what does it look like? It kind of gives you the S, but it's only part of the S. So that's at least a hint. If you graph this out, you would be like, well,
It kind of looks like the square root graph.
yeah, and it kind of also looks like the square root graph. So that's a good point where just logic, working your way through some problem, you think, okay, well, I sort of maybe have part of it, so I should check some of the other numbers. Or it's looking like a square root, let me check some of the other numbers, because I know with some of the other numbers, the square root doesn't work. So you can basically figure out what you're looking at, but either way, you need to pick some other numbers. So let's go with -3 and -4. So is that the -4? You saw, okay, yeah. What did you get for negative? And then what about -3?
It'd just be the opposite.
Um, in this case, yeah, it ends up being the opposite. Yeah. Or not. No, you're good. What do you think?
No, I was thinking like -2 would be like 64 or something, but it doesn't work out like that.
Oh, I see.
I see what you're saying. Because the other one with the square root, it kind of had that add.
You're right, yeah. So let's talk about that for a second. So he's saying the square root has this nice symmetry to it, where a -1 gives me a 4 and a 1 gives me a 4. So it's a good logical guess to maybe hope that you get the same thing here. 2 gives me 64, so -2 gives me -64. And when you do the calculation, it does it. But on Tuesday, when we didn't have the +2, that it would have done. So the problem basically that's happening with this is this +2, it's a left 2, so it's basically pulling the graph out of the center, which means it's not symmetrical. At least that way. Yeah. All right, so let's get it. So -4, -8, so here. And -3, -1. 2, 0, 1, -1, 1, 0. So notice we do get, so once we included some of those extra negatives, we do get the whole picture of the S. Get an S that has been moved to the left too. And then I want to just, creating these, so go ahead, I'll give you another minute to tell me. Add some second ones. What are y'all saying for the domain in this? What about the range? Infinity also to infinity, good. The x-intercepts. Mhm. Good, and the y-intercepts. 0, 8. Any questions or issues there? Yeah.
So like, for the second one that we did, like how it's like. There you go, like, or it's like this, like what's it going on for her? They just be. And why would it have been?
Because, well, it's like we're talking about, because you can't take the square root of the negatives, like there's nothing over here on this graph, so it naturally is. That's fair.
Although it's the same thing, so like, if the difference with one right now, you could keep making other
Yes,
points in the X, Y,
yeah, you can pick a -5, pick a 3,
sit
6.
down and only make positive.
Yeah, exactly. Any questions? All right, so +2 inside is gonna make it, no, it's gonna make it go back to. So I think out of. Out of. Out of the functions from Tuesday, what we have left is we just, so the cube root. Well, actually, so let's do this to get a good function. The cube root of x minus 1, this time the -1 is underneath that works. And let's do this as a class, just to say the little time. So going back to what we saw on Tuesday, the cube root, what shape is that? No, that's the absolute value is the b. The curve. Yeah, so x cubed is kind of this s that's vertical. Cube roots, we'll see later in class, cube root is just the inverse of cubed. So it's an s that is horizontal instead.
On the homework, it was going to like, barely one on the right. You get that.
That's multiple. That's the 1/x. Okay.
Right.
Well, it's not even those. I mean, we're gonna get to compression and reflection. It's not today. It takes some time. But yeah, we'll get there. So this is an S, kind of horizontal S. The -1 is inside, so what should that do to the graph? It should move it to the right. So this should look like the S we saw on Tuesday, but move to the right. Just like the square root though, here, we want to kind of, we want to try to pick some numbers here that are gonna work well for doing the cube root. So look back at your graph from Tuesday. What x values did we end up using? Or no?
Those zeros.
Yeah, oh, -8, -1. But let me, what was your comment or question? It's a good one. What were you asking? Does anybody have the cube roots? I think for 2 out of my 3 classes, I did get to it, so I just wanna make sure.
We opened the B chart.
Uh, we didn't do the graph? Okay, all right, let's finish up the graph. Okay, sorry. Thank you, thank you. All right, so let's finish that out. And so, but we did have the T charts. So what we had there is we went with -8s, -1, 0, 1, and 8. Because for all of these, I'm gonna be able to cube root these, I'm looking for what times itself 3 times, gives me that number. So, and all of these work out cleanly, like the numbers we picked for the square root. So for -8, what times itself 3 times gives you -8? And what times itself 3 times gives you -1? -1, what about for 0? For 1. 1, 1, and then 8, 2, and then let's graph that out. So we have -8s, -2, -1, -1, 0, 0, 1, 1, and then 8, 2. So the cube root graph does look like the x-cubed graph. They're literally what we call inverses of each other. We'll look at that somewhere like week 8 or 9 or something like that. So it's gonna be that same shape, just now horizontal instead of vertical.
So now you have the negative x values. You says you that.
Yeah,
Yeah, a little bit.
yeah, so, but let's look at those two. So let's look at a square root versus a cube root kind of doing, so. Let me. Wow, yeah, let's start it this way. So if I do 5 times 5, what do I get? Go back to your points, because your points are really good when you bring up. So what's 5 times 5? 5. What's -5 times -5? Also 20. So this is why when I do the square root of 25, so if I ask you for the square root of 25, it's actually either gonna be 5 or -5. But if I ask you for the square root of -25, that doesn't work, because no matter which way I multiply these, I get a positive, so this doesn't work. So with square roots, I can't do that, but. What if instead of 2 of them, I had 3 of each? So 5 times 5 times 5. That's gonna be 125. Now what about -5 times -5 times negative? -125. So notice this time I do get the negative. Yeah, and so that's literally the difference. That means when I go to do the cube root of 125, I only get 5 out of that. And yeah, and I can do the negative. So 3 negatives make a negative, so we can do that. Really good, really good. So then this graph, we expect to be this same graph, but move to the right. So when you're picking your x's, so again, here we pick certain x's because we do the cube root of them. When you pick your x's here, we just gotta adjust it for this -1. So on this the first x I'm gonna pick, I want this to be a -8. So what number -1 gives you -8? So -9 -1 will actually get you -10. Yeah, so -7. So I'm just rigging this system. So sometimes we have to do this, make the numbers nice. It's not that it works otherwise, but it makes it nice. So I'm rigging this system, with picking -7 because I know -7 -1 is -8, and I know I can take the cube root of -8. I also want to take the cube root of -1, so what number -1 gives you negative? So I'll need to pick a 0 here. And then what about, what number -1 gives you 1?
1.
Well, 1 -1 gives you 0. So it'd be 2. Wait, I skipped one. Oh, thank you. Yeah, you guys had it right. So the next one will be 1. 1 -1 is 0, and then 2. 2 -1 is 1. Good. And then we also need an 8. So what -1 gives you 8? Then that's gonna be 9. So the cube root is where you gotta play this game on finding, picking certain numbers. So that, but otherwise, then we can plug this in. Should give us the same output, yeah. So -7 -1 is -8, and the cube root of -8 is -2. So that's gonna be -2. That's gonna be -1. And you can work out the calculations to kind of make sure on that, but that's exactly right. And where are we on to that? Yeah, we're just, so let me graph this. Alright, so -7, -2, 0, -1, 1, 0, 2, 1, and then 9, 2. So we do get that same S. Just move to the right. So a minus inside is always going to move your graphs to the right. All right, so what I'm gonna do, we're still missing a couple of the transformations. And, we just basically missing a couple of the transformations that we need to go over, as well as just some problems where you combine the transformations. What we've done though, will still get you all but like 2 or 3 problems out of the homework. So what I'm gonna do is I'm gonna extend the homework due date to be basically due like next Tuesday night. So after our class on Tuesday, so we'll finish. On Tuesday, we'll finish this up, but we'll also start the new stuff. But please, that means go ahead and do all but like those 3 problems, this weekend, so that Tuesday night you just have 3 problems to knock out and you're done. So. But we'll come back Tuesday and finish this.
It's-